So this is a probability scale that we are going to fill in. So here's the scenario. You could ask the question, what is the probability that if you play one number in the national lotto, what's the probability that you are going to win all the money, the jackpot? All right. And if I'd write here, I'll write the word never. I'm going to use a word like never on the left and always on the right. You could use any words. I'm going to write the word never on the left and always on the right. Okay. And in the middle, I'm going to write an even chance. An even chance. All right. Not never, not always, but even, somewhere in the middle. So who would like to raise their hand and tell me where do they think their chances will lie if they win, the chance of winning the lotto if you play one ticket? You play one ticket in your life and the chance of winning that lotto. Terry, yeah, that sometimes happens. Try and log out and then log back in again. All right, to tender, yes. All right, to tender. Tell
So I
me.
think it is
Yes, I'm with you.
even, sir.
Even, you think your chances are going to be even to win the lotto?
Yes, sir.
Oh, you're feeling very lucky to tender. You're feeling very, very lucky. If I had your chance, I'd be playing every day. Okay, you're saying is it even chance that you're gonna win the lotto? All right, I love
Yes,
your
sir. Because
I
you never
love
know
you.
when you're gonna win it. So,
You never know. You never know.
yeah.
But let's answer me this. How many times do you think you're gonna need to play to win?
So in my opinion, I really don't know, but I would say every time I play, I wish I would win.
Yeah,
So I
me
would
too.
say if I play once today, I'll be hoping that I win. If
Yeah.
I play twice, I'll hope that the next time I win. I keep going like that.
All right. I love your optimism. I love the enthusiasm, Tantina. Thank you very much. We appreciate that. Tatenda is feeling very optimistic and he thinks he's got a good chance of winning. All right. Terry's saying 4 times. He just needs to play 4 times. Yondela's saying never and even. Somewhere between never and even. So that's somewhere over here on the left-hand side of the scale. Okay. Karaba saying in a week I'd play 3 times. Karaba, would you win every single time? Karaba saying evil, Letter saying even, Rafila saying even. All right, are we going to develop this scale a little bit more? Then I think you guys might change your mind. I think you might change your mind. But let's have a look. All right, here's another scenario. So you guys are saying either even somewhere or somewhere in this region here. Here's a new scenario. What are the chances of Bafana winning the next World Cup? Somebody tell me. Somebody talk to me. What are the chances? Someone tell me of Bafana winning the next World Cup. Ah, you see, now you're changing your tune. So you guys think you got a better chance of winning the lotto than Bafana winning the World Cup. You want someone saying never. If there is never, then it's never. So you guys are saying, sir, it's got to be around here. Never. Okay, never. All right. Okay. So we understand that no chance. In fact, let me change that to no chance over there in the left. And in the middle, I'm going to say an even chance. We have an even chance of winning here. What about on the right? I'm going to rub out the word always. What could we put on the right? Anybody? Tatenda, sure, I don't know. You're very optimistic. Very optimistic. Certain. Certain's a good word. I like that. I like that. Certain. A certain chance. A certain chance. Good. Certainly will happen. Most likely. Yondela, most likely. Okay, now most likely, I think we can put over here. Most likely. So most likely is we got a good chance, not definitely going to happen, not certain, but most likely. And then obviously on this side, we could say less likely to happen. So the word likely means possibly. Okay. All right. So we've got a scale here with words. All right. Now over here, let's look at certain chance. What else could we write there? What other word that can go with chance that we could write? I'm going to take the word certain. What else could you say? If someone says to you, yeah, it's definitely going to happen. There's a something chance that it's going to happen. What else could we say there? Someone says to you, guaranteed going to happen. You've got something chance that this is going to happen. What else could we say there? What other thing could we say? Doesn't have to be a word. Doesn't have to be a word. What other thing could we say there for definitely going to happen? What kind of chance do we have? Anybody? Doesn't have to be a word. Possible, guaranteed. All right. Perhaps is like a maybe. Ah, there we go. See where. There we go. Really, there we go. Lisa Pandeka, well done. All right. So have you heard it before? 100% chance. 100% chance. Okay. So yes, sometimes we actually use a percentage when we talk about something, the probability of something happening. What's the likelihood of something happening? What's the certainty of something happening? What kind of chance do we have? And we actually use 100% to describe that. Okay, it's very interesting. All right. Now, I'm going to leave 100% for that there now, and I'm going to write 100% down here underneath at the end for 100% chance, 100%. Then what will go on the left under no chance? What will be down here? If 100% is on the right-hand side, what number, what percentage must we put down there under no chance? 0%, absolutely. Okay, 0%. There's a 0% chance. Very good. Well done. What must I put in the middle? What must I put under even chance? Yes, there we go. All right. I told you guys you're gonna have fast fingers tonight. Warm those fingers up. Very good. Yes, yes. Avuzwa, well done. Good. 50% chance. Good. Now, I've drawn the scale to scale. What do you think we should have under less likely? Less likely? What should I have? Sonia Dube, well done. Fast fingers. Well done. Yes, the answers are coming in. Good, good, good. Very good. So 25%. Good. And then most likely? We're switching to most likely now. There we go. Well done, Tatenda. Well done, Vivan. 75% chance. All right. So we can also express the probability scale, not just with words we understand. We can also express it with numbers. And here we have percentages from 0 to 100%. Okay. So you could say, what's the chance of Bafana winning the next World Cup of football? 0%. Okay. 0%. All right. Now, if we can express probability or the likelihood of something happening or the chance of something happening with words and also percentages, we can actually take these percentages a little bit further because percentages can be expressed in a different way. Can they not? What other way can we express a percentage numerically in maths? What other way? Someone raise your hand and tell me. Come on, explain to me. What other way can we express a percentage? You do it all the time. Raise your hand and speak to me. Someone explain. We've got some answers popping up in chat. Got some answers popping up in chat. Yes, you guys know. All right. We can express percentages as decimals and fractions. All right. Now I'm going to do a fraction first. Let's do fractions first. In fact, sorry, let's do decimals first. Let's do decimals first. Okay. what kind of decimal should we have for an even chance? What kind of decimal should we have for an even chance? In chat, anyone? What kind of decimal should we have for an even chance? Even chance in the middle. What kind of decimal should we have over here in the middle? What kind of decimal? Yes, you guys know this. You know this. All right. It's 0,5. Very good. Okay, let's switch over to most likely 75%. What decimal do we have there? Most likely 75%. What kind of decimal do we have there? Very good. All right, you guys know this stuff. Okay, so we can have 0,75. All right, and on this side we can have 0,25. And I bet you guys know we can have 0,0 for no chance and 1,0 for 100% chance. Okay, so we can express percentages as decimals. We can also express percentages as fractions. I'm going to use the green color for that. Okay, whoops, I don't want to show you the question because I know you guys, when you see a question, you just want to answer it straight away. So let's move that down and write here in green. Now, fraction, what kind of fraction should I put? What should I put for an even chance? What fraction should I put for an even chance? 0,5, very good question. How do I get the 0,5? Okay. Let's do it like this. I'm going to write it next to it. Okay, so 50% can be written as a fraction, as 50 over 100. Okay, and if we simplify this, it'll simplify it down to something like 5 over 10. Okay, you can go further if you want. You could, well, let's just leave it like that. That can be simplified to 1 over 2, which is a half. Okay, so 50% can be written as 50 over 100, which can be written as 5 over 10, which can be written as a half. And a half, shown as a decimal, looks like that. Okay, so that's how we can go from 50% to 0,5. Okay. So 1 over 2, I'm seeing guys say 1 over 2. We could use any fraction we wanted, really. We could use any fraction we wanted. I'm going to say 5 out of 5. Okay, so I'll write the end one here. 5 out of 5. That's not a good one. Let's say 100. Let's keep it 100. No, let's make it interesting because 5 in the middle will be 2.5. Let's make it 10. 10 out of 10 for 100 and 0 out of 10 for no chance. You've got no chance. Okay. What fraction then will we have in the middle? If it's 10 out of 10 for 100% and 0 out of 10 for no chance, what fraction do we have in the middle? What do we have in the middle, ladies and gentlemen? Ah, there we go. 5 out of 10. 5 out of 10. Okay, so that's half. Because 5 out of 10 is the same as 1 over 2, isn't it? That's a half. So 5 out of 10 is a half. And a half is 50%. You got a 50% chance. Okay. Now, there comes the hard part. How could we write most likely as a fraction? Whoa. This is what I was thinking about the denominator. What could we write about most likely as a fraction? 3 over 4. I like that. 3 over 4. Absolutely. 3 over 4. In fact, having a 4 denominator is the best way. That's the best one. I'm going to change it up. That's actually the best way to do it. So we can put 4 over 4 and 0 over 4. And the middle one is 2 over 4. And the 75% will be 3 over 4. And the 25% will be 1 over 4. That's the best one. Very good. Who was the first person to say that? Ofanse. Well done, Ofanse. Good job. Using quarters is actually the best way because there's 5 fractions that we can express here. I forgot about the 0. There's actually a 5th one. Okay, we just think about 1, 2, 3, 4. But forget that 0 is the 5th one we can show here. Very good. Nice. Okay, so what I'm trying to do is to show the probability scale and how we can express the chance of something happening, no chance to 100% chance, or certain. Okay, I'm going to remove 100% here, and let's put the word certain there, because we've got numbers at the bottom. Let's put certain. And we can also express the probability scale using numbers. We can express it as a percentage, we can express it as a decimal and a fraction. Okay, and excuse me, later on when we do calculations of the probability, that the people that write the questions for this have to tell you which one of these ways you must express your answer. Sometimes they will ask for a percentage, sometimes a fraction, sometimes a decimal. Okay, often they will stick to the fractions, and I'll explain why when we get there. That's going to be next week, Tuesday. But often they want you to stick to the fractions because the probability formula is a fraction. So they want to see what numbers you have in your fraction. But we can change it to anything we want. We can change it to a decimal or percentage. And sometimes they'll do that. They'll say, calculate the probability and then write it as a percentage. And you need to know how to change to a percentage. You know that if we need to go from a fraction to a percentage, all we have to do is times by 100. And that'll get us to a percentage. Okay. All right. And how do we get from a percentage to a decimal? Well, let the calculator do it. Okay. You know that 50% is 50 over 100. You press equals on your calculator, it'll simplify that for you and go into decimal form. It'll simplify it in decimal form for you. All right, let the calculator do the work. All right, so we can change between these depending on how what the question is. All right, here are some scenarios now. I talked about the lotto and Bafana. We're going to talk more about more scenarios, and you're going to tell me, using this scale, what the chances are. Okay, now, before I show you, okay, let's see. Tatenda, are you there? I've got your question here. Oh, I think he's going to get a cup of coffee. Oh, he's there. Tatenda, you there?
Yes, sir.
Excellent. Here's your question. Number 1, there it is. What are the chances of winning the lottery if you buy a ticket for every week for 2 months? Give your answer using words. You can use the words on the screen if you want. What are the chances of winning the lottery if you buy a ticket every week for 2 months straight? What do you think?
So I would say most likely,
Most likely,
um,
yo.
because I have faith in myself.
Okay, now I'll agree with you. You'll win something. Whether you'll win the jackpot, that's a different story. That's a different calculation. But I think you're most likely to win something. Okay?
Yes,
So I would agree with you there. You are most likely to win something. Could be 10 Rand, could be 100 Rand, could be 1,000, maybe even 10,000. As the number gets bigger, the chances get less.
yes,
Ah,
sir.
so all right. Thanks, Attender. There's some people in the group who disagree with you, but I think they're thinking about the jackpot. But if you're talking about some money, all right, let's be specific. So we can say here, most likely to win something. Because if you get like 3 numbers right or 4 numbers right, you win something. Okay, so most likely to win something. So this question should have been specific. When they said here winning the lottery, maybe they meant the jackpot. If it's a jackpot, oh, to 10, I'd have to disagree with you. But if you play every week for 2 months, I think you're going to win something. All right, yeah, which is 3 over 4. You can express it as a fraction that way. Okay, who would like the next question before you see it? Raise your hand. Who would like the next question before? These aren't tricky, difficult questions. Who would like the next question before you see it? Ah, there we go. There we go. All right. Karabo, you there? Look at your screen. There's a little, there we go. Karabo, you there?
Yes, sir.
All right. Here's your question. How likely is it that you will pass math literacy this year? Give your answer using words. How likely is it that you will pass math literacy this year?
Certain. It's certain, sir.
It's certain, absolutely. There is no other answer. Certain.
Yes,
Thank you, Karabo. Well done. Thank you. Certainly. Definitely. Thank you, Karabo. All right. Who would like the next one? Who would like the next one? Emmanuel. I see that hand. All right, Emmanuel. There's a little prompt. Emmanuel, you ready? Here's your question.
Yes, sir.
What are the chances of rain in your area today? Use words. What's the chance of rain? Let's say tomorrow. What's the chance of rain tomorrow in your area? Use words. What's the chance of rain tomorrow?
What's 50%?
50% even chance. All right.
Even chance.
Excellent. Thank you very much. Thank you, Emmanuel.
Thank you, sir.
All right. I'm going to write there even chance. Good job. Okay. I can see your hand. Sakila will ask you next. So we're going to say even chance. 50-50. All right, Sakila, here is the next one for you. Very interesting. All right, there we go. Just unmute yourself quickly. All right, Sakila, you ready for your question? Just follow the prompt there. All right, what is the probability of a
Yes,
pregnant?
sir.
How are you doing? All right. What's the probability of a?
Yeah, doing good. Wait, you asking me if I'm okay?
Yes, I did. Yes, question 4 for you. Ready?
Yes, sir.
What is the probability of a pregnant woman having a male child? Give your answer as a percentage.
Less likely.
What? Why?
It's less likely.
Why?
Because a ratio of girls and boys in the world is 1 to 2.
Ah.
There are more girls than there are in boys.
Ah.
And there's more, but it's on science, so I can't explain that one.
Okay. Okay, so I agree with you that there's more girls in the world than boys. But when a lady has a child, are you saying science says that that child is more likely to be a girl?
Yes.
Ah. All right. So what percentage? Give us a percentage.
Percentage.
There's the
I don't
percentage.
remember the percentage.
There it is there on the screen.
It's 25. Oh, it's a 50%. So it's an even
50%.
chance.
Even that's the one. That's what I thought as well. Even chance of 50%. Okay,
That's
so
have a point though.
yeah. No, I agree with you. I think there are more ladies in the world than gentlemen. But I think the chances that you're going to have a boy or a girl when you have a kid is 50-50. You don't really know. It's like, oh, is it a boy? Is it a girl? All right. Who's next? Thank you guys in chat. 50-50. Ah, yeah, I see. You don't have to worry about chat. You give your own opinion, eh? Okay. Letabo, you ready? Check your screen, Letabo.
Yes,
There. How
sir.
you? Are you right?
I'm good. How are you?
Good, thank you. Letabo, question 5 is yours. What is the likelihood of when you toss a coin, you're going to get heads when you toss the coin? You get heads and tails on a coin, right?
Yes.
So the coin has two sides. One side's heads, one side's tail. What's the chance of you going to get heads when you toss the coin once? Give your answer as a decimal.
I would say 1/2, sir.
Okay, 1/2 is like 50%, all right? So I'll write there 1/2. But what is that as a decimal?
Oh, 0.5.
Yes, 0.5. Absolutely. Good job. Good job. Well done. Thank you very much, Letabo. Okay, let's see who's next. I see someone with their hand. Katlejo. All right, Katlejo, check your screen there. You should see a little. Oh, there we go, Katlejo. You're with us.
Hello, sir.
How are you?
I'm good, thanks, and you, sir?
Good, thank you. All right. Here we go. Here's an interesting one. Question,
sir.
oh, what is the probability of rolling a 6 when you roll a die? Now, a die, don't be confused by the word die. Die is singular for dice. Die. So 2 dice, 1 die. So dice is plural for die. You know when you roll a dice?
Yes.
Okay. So 1 dice, 1 die. Okay. What's the chance of you getting a 6 when you roll 1 die?
So I would say 0 chance.
6.
Yes, it's like, to be honest, say when you play dice, it's really hard for you to get a 6. You get
No,
a
you're
6.
right. You're absolutely right. It is hard.
Yes.
It is
It's
hard.
really
So
hard for you to get a 6. Yes.
yeah, it feels like that. It does feel like it. When am I going to get the 6? Especially if you desperately need a 6, you feel like you're never going to get it, eh?
Yes. But
Okay.
as some like other students are saying that it's less likely.
Less likely. Okay, yes, it is. You're right. Like you said, you feel like you never get it, therefore it must be less likely. All right, now stay with me now. Stay with me. How many numbers are there in a dice?
We have 6.
How many?
5,
Yes, there's 6.
4,
Yeah.
3.
Yes.
5, 6.
All right.
Yes.
Can you agree with me that when we roll the dice, we could get any one of these numbers? We roll the dice, you could see any one of them.
Yes.
We don't know which one, but it could be any. All right. So you roll it. You could get a 4. You could get a 1.
Yes.
Okay. Do you agree with me that the chance of getting, for example, a 2 is the same as a chance of getting a 6?
No.
Why not?
You get a 2 a lot.
Okay.
Before you get a 6.
It does feel like it, doesn't it?
Yeah. So I would say that one is certain, like certain chance for you to get a 2 before you get a 6.
Yeah, it does feel like it. It does feel like that. Okay.
Yes.
When you need a 6, it feels like you never get it. I agree with you. I'm laughing because I've been there, especially when you're a kid. And like we used to play this game called Snakes and Ladders, and you couldn't even get on the board unless you rolled a 6.
Yo, it's so stressful.
It's stressful. You just want the 6, and you feel like you never ever get it.
You'll never get it. Yes.
Yes. Okay. All right. So let's look at the same experiment again. Okay. What if I was to tell you that this 6-sided dice, there is an even chance to get any of the numbers. So it's not weighted to one side or anything like that. There's an even chance to get any one of these numbers. You could get a 1, a 2, a 3, a 4, a 5, or a 6. There's nothing on this dice that's going to make you get everything else but a 6. Do you agree with me?
Yes, sir.
Okay. So how many possible numbers could we get? They're all here, right? How many are there?
Possible numbers that we can get.
Yeah, there they are.
Say
6, 5, 4, 3, 2, 1. How many numbers are there? We got 6. We got 6 numbers. Okay.
Yes.
So there's 6 numbers. There's 6 possibilities, right?
Yes.
Okay. So look, I'm going to draw a fraction. There's 6 possibilities. The number 6 is one of those possibilities. So what number do you think I should put you on top of my 6 to show the chance of rolling a 6? If the number 6 is one of those possibilities, what number should I put at the top of my fraction here?
I think 1/6.
Very good. Very good. There's one number out of 6 that we could get. It's an even chance compared to everyone else. Very good. Thank you very much.
Thank you,
Thanks,
sir.
Ashley. Thank you, Kusheko.
Thank you, sir.
All right. Okay, so if there are 6 possibilities on a dice, what's the chance of getting one of those numbers? For example, a 6, even though it feels like we never get the 6. The chances are all equal. So it's one of the numbers out of 6 possible numbers. So it's 1 out of the 6. Okay. All right. I think we're starting to get the hang of it now. All right. Who's brave? I don't know if you guys feel like it's getting more difficult, but it isn't really. Maybe it is. Maybe it is. All right, so we put the answer here. 1 out of 6. Who's brave enough? Oh, someone that's played with cards. Someone that plays cards and knows about playing cards, raise your hand. I need to speak to that person for the next one. Who's played with cards? Tatenda. All right. Yondila, I saw the hand, don't worry. Ah, all the hands goes up. Okay, Tatenda, you've played with cards before, right?
Yes, sir.
Okay, then you must know about cards. You're going to answer the next one for me. Here we go. I don't know if you can see the question there, so I'm going to make a little space. It says, what are the chances of drawing a numbered card from a pack of playing cards? Give your answer as a fraction and then a percentage. Now, let's go through this carefully. How many cards are there in a pack of cards?
The 54 in total, so 52, I think.
52, absolutely. Now, ladies and gentlemen, how is he getting 52? Please explain to Tina how we get 52. How many suits are there?
Sorry?
How many suits are there in a pack of cards? There's 4 suits.
The 4 suits there.
Yeah, all right. We got hearts,
Diamonds,
diamonds. What else do we have?
black hearts, that's how we call them.
What?
Or black hearts or shovels.
Black cards, shovels, that's spades. Oh, geez, how am I going to draw a spade?
That's spades.
Guys, please forgive my drawing, right? Oh my
And then we
gosh.
get the trees.
Yes, this is like a tree. I think it's got 3 things on it. Oh gosh. All right, guys, please don't laugh, eh? All right, so there's the 4 suits of the pack of cards. Okay. How many cards in each suit?
4, sir.
There's 4 suits, but how many cards are there in each one? Like, how many hearts do you have in a pack of cards?
In a whole pack of cards.
How many hearts are there?
I didn't count that.
Okay, well, let's start from the beginning. What's the first one?
Oh, it's so hard. So it's A.
Ace. All right, good. And it goes then? What next?
And then it's J.
Okay, we'll do that we'll do the face cards at the end. What's the next number after an ace? Because ace usually represents
2.
1. 2, very good. And it goes next 3, 4.
Then it's 4, 5.
Yeah, keep going.
6.
Yeah.
7.
Yeah.
8. 9.
Yeah.
10.
Yes.
And then
Okay.
K and J.
Yes. All right. So 5, 6, 7, 8, 9, 10. All right. Jack, Queen, King. All right.
Yes.
Okay. Now, how many in total are there in the hearts? How many do we have there?
13, sir.
Absolutely. 13. All right. And there's 13 diamonds,
Yes, sir. And the 13.
13 shovels, yes, and then 13 of this last one. Yeah, we call it clubs. All right.
Plums.
So we've got 4 13s. You guys, if you say 4 times 13, that's why he said 52. Okay. So each suit has got 13 cards in. 4 times 13 is 52. Now, why is Teacher Dale spending so much time on cards? I'm thinking some of you are thinking, why? Because this question often comes up in a probability question in the exam. Coins, cards, dice, they always come up. All right, this card question is famous for the exam. So this is why I want to spend a little bit of time on this. All right, so we've got 13 in each suit. All right, Tadeni, you still there?
Yes, sir.
Okay, now, numbered cards. Which cards are numbered?
2,
We got the number.
3.
Yes, absolutely. Yeah, 2, 3,
2
4,
until
5.
10, sir.
Absolutely.
From 2 to 10.
Yes. So these ones here are numbered. Ladies and gentlemen, he didn't say ace is numbered because it would be a 1. Ace is almost like a face card. It's not numbered. All right. So if the question is numbered cards, let's go back to the question. All right. Get your calculators ready. Tatenda is going to get his
Okay.
ready. What are the chances of drawing a numbered card from the pack of cards? Give your answer as a fraction. Tatenda, how are we going to do this?
So I would say most likely.
How many of those numbered cards are there? That's the question, eh?
There are 9, sir. Numbered
There's-
cards is all 9 in total.
There's 9. All right. So how many numbered cards are there in a pack?
In the whole pack, then
You know,
9 times 4, 36, sir.
very good. 9 times 4 is 36. All right. Now we need to show this as a fraction. So what are we going to put at the bottom of our fraction? How many possible cards are there in a pack? You said it earlier.
Possible cards, sir.
All of
That's
them.
50,
52. And how many numbered we got? You said 36.
36, sir.
So you got a chance of 36 out of 52 to get a numbered card. If you put all the numbered cards in a bag and then you
Yes, sir.
ask someone to reach in there, the chance of you pulling out a numbered card is 36 out of 52. Tatenda, how do I change that into a percentage?
So if you into percentage, so don't you? So you first change it into a decimal and then you divide by 100.
You can do that. You can do that. It'll work. Or you can just multiply straight away by
100.
100. Yeah. All right, let's do that. What are you getting?
So I got. So must I give you the answer in fractions or decimals?
This is the number you give me is the decimal fraction. It's a fraction.
Okay, so it's 450 over 7.
All right. Oh, 450 over 7. I'm getting 900 over 13. Check your calculator there. 36 over 52 times 100.
Yes, sir.
All right. I'm getting 900 over 13. And then when I press my SD button, I get 69.23%.
I
Just
get
check your.
64.28.
We're doing something different. We're doing something
So-
different here.
So it's 36 over 52. Oh, I said 56. Sorry, sir.
Yeah, it's okay. It's fine. There's little
Yeah,
mistakes
I
happen
got
all the time.
yeah.
Right, so 69,
Correct,
so 69,2307. I'm going to write there 69,2307%. And if we round it off,
Round it off is gonna be 69,231.
that'll be if we're rounding off to the third decimal, we're going to worry just about the second decimal. So we're just going to worry about the 3. And the 3 is not going to change, eh?
Oh, so it's not gonna change there.
Yeah. All right. Excellent. So then the answer will be 69.23%. Tatenda, thank you so much for your help. That was awesome. Thank you.
Mhm.
All right. I hope you guys see how we did that. So in any scenario, we can actually change it into a fraction. And the bottom of the fraction here, okay, is the total possible. And the top of the fraction here, I'm going to rub out these little horrible looking diagrams, which teacher Dale doesn't know how to draw. The top of the fraction here is the observed number. I'm just going to write observed. How many are observed that are possible and the total possible? Let's write observed possible. Okay, so we know there are 36 numbered cards in a pack out of a total of 52 cards in a pack. So we write 36 over 52. And if you want to change it to a percentage, you just times by 100. Okay. I hope you guys can see that. Yes, the answers are coming into chat as well. Are there any questions about that? Because we're going to try this again. Whoa, that was a big one. Who's brave enough to want to try the next one? Whoopsie. Who's brave enough to want to try the next one? Tatena did an excellent job there. Who's brave enough? Don't make me do it, guys. Please don't make me do it on my own. Anybody out there want to try the next one? You haven't seen it. I know what you guys think you should. Sir, show me the next one, then I'll think if I want to do it or not. I'm not going to show you. We can do this. Who's brave enough? Oh, everyone's spooked now. All right. Tukulo, I see you raise your hand. Check your screen there. Tukulo, just check your screen. You should see a little option to. There we go. How are you doing?
I'm good in you, sir.
I'm good. You're confident. I can hear in your voice you're confident. You ready?
And say I'm not sick, girl.
Here we go. All right. There's the scenario. Okay. It's the one about Thomas. What is the probability that Thomas was born first in his family if there were 5 children in his family? Give your answer as a decimal. All right. So we need a fraction.
Oh,
What's going to be at the bottom of our fraction? The total possible number of kids in this family. How many?
5.
5. All right. So let's pretend that you knew you were going to have 5 kids. Okay. And this boy, Thomas, they're all been born now, but he's looking back and he said, I wonder if we actually knew that we were coming, how would we work out what's the chance of me coming first? Thomas. Only Thomas. He has to come first. All right. So let's pretend there's Thomas, there's Timothy, there's Sandra, there's Bianca, there's Olwetu. There's 5 possible kids. All right.
Yes, sir.
What's the probability that this one boy, Thomas, was going to be first? Because it's any one of them could have been first.
Yes, sir.
What's the probability of him being first? What should be at the top of my fraction?
1, sir.
Absolutely. Absolutely. All right. And a decimal, where's your calculator? Get your calculator, we'll do it together. How do we change it to a decimal? What you getting?
0.2.
I'm getting the same. Well done. 0.2. Absolutely. Fantastic. Tukulo. Well
Yes,
done.
sir.
Well done. Thank you very much.
Okay, sir.
All right. Okay. Who's next? Yes, well done, chat. Okay. Offense. I see you raise your hand. Check your screen there. Offense, how are you?
I'm good. How are you, sir?
I'm good. All right. You ready for the next one?
Yeah.
All right. There it is. I'm just going to shift the rest down. You can read it. That's the green sweet one. What's the probability that you will pick a green sweet from a bag of 7 green sweets?
Okay.
7 green sweets are in a bag. You reach in, pick one. What's the probability it is green?
It's 1/7. Give your answer as a fraction. Okay. So yeah, there's 7 total green sweets in a bag, and they're asking for the probability of picking one. So
Yeah,
it's
you got to be careful now. All right. So they say there's 7 possible sweets. So I've got 7 at the bottom there. How many are green?
7. Okay, wait, what is the probability you pick a green seed from a bag of 7 green sweets?
Yeah. If you did it twice, you picked it out and you looked at it and you put it back, and then you picked another one out and you looked at it and you put it back.
Oh, 7.
And then yes. You keep doing that. You keep doing that. What's the probability one of those 7 that you pick out is going to be green?
7.
You said it. 7. Yeah, well done. Because all
7, yeah.
all 7 of them are green. So there's 7 sweets But how many are green? There are 7 that are green.
7
So
that are
it's,
green, yeah.
yeah. So, and as a fraction now, I haven't written it in the question, but how can we change this to a percentage?
Do you times it by 100?
Absolutely. Absolutely.
Yes.
Which will
It's
give us what?
100%, so it's certain.
Absolutely. It's certain.
100.
100%. What's the chance of you getting a green sweet if there are 7 green sweets in the bag and you pull one out? 100% chance it's going to be green.
100%.
Excellent. Thank
Yeah.
you very much. Good job. Tricky, but well done.
Okay, thank
All
you,
right.
sir.
Thank you. Excellent. All right. How many we got left? We've got 2 more left. Okay. This next one. Who's brave? The last one. What is the likelihood of Bafana win the World Cup? We know what the answer is to that one. So I'm going to push that one aside. We discussed it already. One more. Who's brave? Who's brave? Well done, chat. Who's brave? Raise your hand. Come on now. Last one. And everyone's reading it first. No, everyone's reading it first. Should I raise my hand for this one? Who's, come on now. Oh. So cool. So that hand went up and it disappeared. All right, we've got, okay, offensively, I'm going to give this one to Yondela because Yondela hasn't had a turn. So Yondela, just check your screen there. There we go. Yondela, you hear me?
Yes, sir.
All right, Yondela hasn't had a turn offensive. Sorry, man. Yondela.
So it's Ave. It's just on a different account.
Ah, Ave. Good to hear you again. All right, Ave.
Yes, sir.
What are we going to do? Here, let's read it. If a bag contains 3 red marbles, 2 blue marbles, 5 yellow marbles, determine the probability of picking a blue one. All right, we need a fraction. What's at the bottom of my fraction? How many marbles
10.
are there?
There's
There's
10 in
10.
total.
Very good. What's the probability of picking a blue one?
It's 1, sir.
How many blue?
There's 2.
There's 2. So what should I put at the top of my fraction?
2.
Absolutely.
Yeah.
Okay. We can simplify this to 1 over 5 if we wanted to. All right. But to be honest, they want to see the 2 for the blue marbles and the 10 for the total possible. Okay. While you're with me, Ave, how can we change this to a decimal? What do you get? Oh, he's gone. All right, chat. What is it as a decimal? Well done, Kakleho. Kosi, well done. Yondela, there we go. Ave, good. 0.2. You don't even need a calculator for this one, guys. It's just 0.2. Just 0.2. What if you want to change it as a percentage? Can we give this as a percentage? It shouldn't be difficult. What is it a percentage? Fulham Corsi, well done, 20%. Okay, times by 100, you're going to get 20%. Good, Fancy, good job. All right, ladies and gentlemen, I hope you understand how this works now. Okay, we're going to talk more. We're going to talk more about this next week, Tuesday, when we do the probability calculations. But we can express probability using words and then numbers. And with numbers, there's 3 options: percentage, decimal, or fraction. Okay, now when we do probability, you should start with the fraction and then go from there. Change it to a decimal or a percentage from there. Always start with the fraction because like I showed up here, I'm going to go back up to the formula just to remind you all, because we're going to see this formula again. We're going to use it like this again next week, Tuesday. In this example here with the playing cards, the total possible options that you could get are 52 playing cards in a pack. But the ones that we are talking about, the numbered cards, we worked it out. There's only 36. All right. So it's 36 out of 52. Observed possible, 36 out of a total possible of 52. So that theory there, that formula we're going to use, I'm going to introduce it to you on Tuesday, but that's how we're going to use it. And from there, it's easy. We can change it to a decimal or a fraction. And that's all that probability calculations are. That's all it is. Okay. Hugo, I think we're ready for the poll. You should see the poll link pop up soon. There we go. No quiz tonight, Tuesday night. Only see the quiz on Thursday. On Thursday, we're going to talk a little bit more about theory. We're going to talk about an experiment. We're going to do an experiment. We're going to predict something in the beginning, and then we're actually going to do an experiment and see the results and compare what we predicted in the beginning to the results at the end and compare the two. And this is what mathematicians do often. We can do that in everyday examples as well. All right. Okay. Yondela. I'm very glad. Imanati, we are going to start revision classes at the beginning of June. We're hoping that'll be coincide with the start of exams. It won't be like that for all schools because every school is different. But we are starting revision classes in the beginning of June, and we're doing, I think, 4 weeks of revision. So we're just going to revise, and looking at exam questions. Okay, so that revision class, that course when it starts will be very important. Yes, every Tuesday and Thursday. Every Tuesday and Thursday. No, it's not going to be a boot camp. Boot camp is a little bit different. So the grade 12s will do a boot camp. We might do, in fact, we are going to do a boot camp towards the end of the year for the final paper. We're not going to do a boot camp now. We're going to do 4 weeks of revision classes. Okay. Yes, offensive. Absolutely. That's the last thing we're going to do is tree diagrams. Okay. That's so early. 29th and 30th of May. Imanati. Gonna have to hang in there. Also, what you can do, Imanati, is I'm just check the calendar when we're gonna start the revision courses, but we're trying to time it with, as far as we know, as many schools who are starting their exams at the time. We did do a lot of revision. We did end of term revision for 2 weeks at the end of term 1 on the topics, quite a few topics that we covered in term 1, like finance, measurement, things like that. That's all on YouTube. So if you look on YouTube, you will see those revision classes there.